Good morning. Myself, Dr.Ashwini.G, Assistant Professor, Department of Mathematics, Government College for Women, Mandya. Today I am presenting a paper, The Effect of Heat Generation Absorption on Unsteady MHD Flow over a Truncated Cone Embedded in a Stable Thermally Stratified Environment. So this belongs to laminar boundary layer theory of fluid dynamics. So before going to the paper, we shall see the laminar and turbulent flow definitions. In laminar flow, the fluid particles run in an orderly manner, whereas in turbulent flow, they run in irregular manner. And the boundary layer is nothing but a very thin layer in the neighborhood of the body where the viscous force is significant. The term unsteady in the research paper means it is the flow in which fluid particles vary with time. And heat generation will rise the buoyancy force. As a result, variation in heat transfer characteristics can be observed. And MHD is magnetohydrodynamics. And this is the flow model of the research paper. And also we have a stratification term here. It is nothing but the density of the ambient fluid is non-uniform and varies with height. If it is due to temperature, it is termed as thermal stratification. And lighter fluid particles lies over the heavier means, then it is called stably stratified. And the objective is to study the effect of magnetic and heat generation absorption parameter effects. And these are the governing equations and initial and boundary conditions. And since we have to convert the dimensional equations to non-dimensional, we use these similarity transformations. We obtain these non-dimensional equations which are non-linear, and also the transformed boundary conditions. And these are the skin friction and heat transfer coefficients in the form of Nusselt number. And we use numerical method to solve such problems. And these are the step sizes we use for convergence. And before discussing our results, we compare our steady state result with Case, Coward, and Sebastian Bradshaw, and the results are in good agreement. And our first results are the effect of magnetic parameter on skin friction and heat transfer coefficients. And you can see that both skin friction and heat transfer are reducing as magnetic parameter is increasing. And the corresponding velocity and temperature profiles are also exhibited. And the second result is effect of heat generation parameter on skin friction and heat transfer coefficients. So this heat generation parameter increases skin friction, whereas it decreases the heat transfer coefficient. In result, there is an overshoot in the heat transfer rate you can observe in the figure 4b. And the next result is effect of heat absorption parameter. This decreases the skin friction, whereas it increases the heat transfer coefficients. And also you can see that momentum boundary layer thickness is increasing, and whereas thermal boundary layer thickness is decreasing. So the conclusions are magnetic parameter reduces the velocity of the fluid, and heat generation increases thermal boundary layer thickness, whereas heat absorption does the reverse effect. And unsteadiness has a significant effect on both temperature and velocity profiles. These are the references, and thank you.